Hi, in this video I'm going to demonstrate how to build a simple sine wave synthesizer which responds to MIDI keyboard input. And what I've got here is Max version 6. I have created a new patcher, which you would do by going File, New Patcher, and I'll just make that the size of the window so we can see it all. And we have on the right hand side we've got our Explorer, which gives us all of our sort of objects. So this system is on a iMac, and I have a keyboard connected through to the MIDI input on my computer. So the first thing that we're going to have a look at is getting MIDI data into this Max patch, and we can do that by, if I search on here for MIDI in, maybe sort of around there. Yes, we've got our MIDI in object here, which outputs any MIDI data that's received onto from in our computer. So MIDI in is just like a sort of a thing here, and what will happen is any raw data from our MIDI system will be output here. So if I create a print object, this allows us to see what's actually input. So I connect the output of MIDI in to print, and now what will happen is when I lock the patch and we receive some MIDI information, if I have a look at the Max window, if it's got anything there, you can click this button to clear it all. And now if I press a key on my computer, on my sort of MIDI controller, this shows me that I've got MIDI information which is coming through. So if you're not getting anything, it could be that you're not actually connected to your correct device. So if you double click on MIDI in, it will bring down this drop down window, and I'm connected to my USB MIDI device. So make sure that's the actual keyboard that's connected to your computer. So selected that. So MIDI in outputs raw MIDI data. We need to do something sort of with that information. So the next most useful one is if we create a X note in object. And this basically, what X note in will do is it passes the information that it's received from my MIDI input. So it basically allows us to see what MIDI key has been pressed, what's the velocity, if it's a note on, etc. So to get information on X note in, if you right click on X note in object and then look at the help file, it's the Max MSP note system. Help system is sort of really good for this sort of thing here. And we can even sort of cut and paste stuff from there. So I might do that for this one. So if you unlock the patch, select what you want to steal, and then delete that, and then paste that. This is basically what I'd had before. So I've got MIDI note in, which receives all MIDI information, and then I've got X note in, which basically parses that and separates it into several different boxes. So you'll notice these are labelled. So now if I run my patch and I press my keyboard, my MIDI keyboard, you'll notice that this information is changing. So if we make this bigger to actually have a look at what's going on, and now it's disappeared off my screen. So when I press a note on a MIDI keyboard, it sends a note number. So this is a number between 0 and 127. And so that would be the pitch here. So a low number would be 0, a very high number will be 127. This second bit of information is how hard the key is being hit. So if I try and hit my key lightly, it gives us a number of, between 0 and 10. If I hit it very large, the highest value it will output is 127. So that we could use that to alter the amplitude of our signal when we create it. Now if I press a key, this box, it contains the note 1. So if it's received a note on, that will be 1. And if it's received a note off, if I let go, then that number will be 0. And then this third one isn't changing much, but it just shows you what the MIDI channel is that I've received there. So I could use this to create a synth by basically, we want to map this pitch to a cycle object, so we generate a sine wave. So if I have a look at cycle, and it would be cycle and then squiggle. Now our cycle object is expecting a frequency. So if you want to play a tone at 1000 Hz, 2000 Hz, 440 Hz. However, our MIDI information is received with a MIDI note which goes between 0 and 127. Now to match these two up, there is an object called MTOF which converts MIDI note number to frequency. So it's a very useful object that we can use for that. So if we patch the output of the pitch, I've sort of done that wrong. If I patch the output to the input of MTOF, I've kind of done that wrong again. I'll do it that way around. Make sure it's not connected to that one. And I'll put another number box on here so I can see the number that's output. It just makes it easier to actually see what's going on with your program. So if I press lock the patch and then press a number, this MTOF will actually output the actual frequency value. So MIDI number 45 is a note which has a pitch of 110 Hz. So MIDI key number 60 has a pitch of 261. So if I wanted this keyboard to respond to this data, I use the cycle object which will generate a sine wave whenever it's received a note number there. So what happens in this patch is we receive all of our midian data which comes out of this outlet and then goes into our xnotein object. Xnotein separates that MIDI data into the note number, velocity, if it's note on or off, or MIDI channel. The pitch information is changed between a MIDI note number to a frequency which is in Hertz, and then this frequency is sent to cycle which will then start generating a sine wave. Now if we want to actually hear something, we need to add EZDAC at the bottom and we output our sine wave to one of the channels on there. So if I just make this a bit smaller because we've got some more in. So now if I lock my patch and I press a key, I'm getting some sort of sine wave output. So I'll just turn that off. Now what you may have noticed is this, if I touch the keyboard and send it a MIDI note, it will constantly play that cycle object up until a new note is played. So we need to have some method of being able to turn off this information. So what we could use is this note off information there. And what we really need is some way of adjusting the amplitude of this cycle object here. So we can have a multiply object. There we go. So multiply signal. So if I delete this and put it in the path, the output of our cycle oscillator will go into here, and then the output of that will go to our thing. And we can trigger, we can turn on this by sending a number to here. So if I send it the number 1, what it will do is it will multiply every sample by the number 1, so it will actually send everything through at a good route. If I send it the number 0, so I add another message with 0 in there, this will then multiply every sample that's received by the number 0, which will make it silent. So if I turn this on, we'll lock that and turn it on, press a number, I can turn this on and off by sending it a 1 or a 0. Now what I could do is this basically just demonstrates how if I multiply the audio stream by 1, it sends it through unaffected. If I multiply it by an audio stream, multiplied by 0, it silences it. So I could use this note on and note off, which actually goes between 1 and 0. So removing these and then outputting here, I can route the output of this patch into this multiply, and now when I've received a note on, it will start playing, and when we received a note off, that will then mute the audio. So now it will stop once I put a key on. So we'll put this on and I'm pressing a key, and you'll see that our note on value is 1, so it means it is multiplying every sample of the output of the oscillator by 1, and when I release the key, that goes to 0. So now I've got a synth which just basically plays various tones whenever I press. So we've got a sine wave synthesizer which is controlled by the note on and off and the pitch values as well.